So we're going to talk about the common base method of solving exponential equations. So let's look at our first problem. So remember, with common base, the idea is to get on both sides of your equation one single base that is common, so the same base, to one single exponent. So we're already set up pretty good for this problem in that I have a single base on both sides, so one base of 3 and one base of 9. So the only thing really left for me to do is to write them as the same base. Now I know that I can't write 3 as anything else, but I can write 9 as 3 squared. So I'm going to have 3 to the x plus 1 is equal to, and I'm going to replace 9 with 3 squared to the 2x stays the same. Then I'm going to use power to power, power rule. So a power to multiply is 3x to the x plus 1 is equal to 3 to the 4x. Okay. From here, we know at this point that if you have the same base set equal to each other with a power, that those powers, the only way that can be a true statement is if the exponents are the same. So we can set up our exponent equation, x plus 1 is equal to 4x, and then we can just simply solve. So I have 1 is equal to 3x, divide by 3, and I get that x is equal to 1/3. Okay? Number 2, again, I want to write this as one base to one exponent on both sides. So I can see that I have a base of 9. And 81 can be written as a base of 9. But notice this is 1 over 81. So it's not just 9 squared, because that would be 81. It'd be 9 to the negative 2. That negative makes it go down to the bottom. And the squared is what gives me the 81. So I have one base, the same base, set equal to each other with only one exponent. So I can write my exponent equation and solve, and I get that negative 3 is equal to x. Next, I have, this time I have 3 different bases, so I have to figure out what I can use here. Now see, 2 is my smallest, so that's probably where I'm going to start, and I know that I can write 64 and 4 as a base of 2. So 2 to the 6th is 64. So that's going to stay to the x minus 2. So this is, remember, 2 to the understood 1 times 2 squared is 4 to the 2x plus 2. So now we need to do power rule. So power rule says power to a power we multiply. So that's 2 to the 6x minus 12 is equal to 2 to the 1 times 2 to the 4x plus 4. So I still have a problem. So I have that common base happening, but I don't have a single base to a single exponent on both sides of my equation. So I need to fix this right-hand side. Okay, in order to do that, I'm going to use product rule. Product rule says when I multiply two like bases, I add their exponents. So that's going to give me 2. So 4x and 1 plus 4 is 5. So now I have that same common base raised to a single exponent, so I can set up my exponent equation and solve. Now there's multiple ways that you can start this. Personally, I'm going to subtract 4x on both sides, and I get 2x minus 12 is equal to 5. I'm going to add 12. So I get 2x is equal to 17, divide by 2, and x is equal to 17 over 2. Okay, and the last one. Again, I'm going to look at that smallest number to see if I can use it as a base, and I can. I know that 5 squared is 25, and 5 cubed is 125. So 5 squared to the 3x is equal to 5 to the x times, now I know 5 cubed is 125, but this is 1 over 125, so it lets me know it's going to be a negative 3. So the first thing I'm going to tend to is the power to a power. So I have 5 power to power we multiply, 6x equals 5 to the x times power to a power we multiply, negative 6x plus 3. So again, we have all the common bases now, but we don't have a single base raised to a single exponent. So on the right-hand side, again, I'm going to use product rule. So two like bases, when they multiply, we add their exponents. So x plus a negative 6x is negative 5x plus 3. Just combining like terms. Now I can set up my exponent equation and solve. So when I add 5x, I get 11x is equal to 3, divide by 11, and I get x is equal to 3 over 11.